In this example we're going to find the centre of mass of the function y equals root x between the x-axis and the line x equals 4. Let me just start by saying I could use the formulae directly that we generated previously, and in an exam situation I dare say that's what I would do. However, for this problem I'm kind of going to work through it a little bit from more from first principles, simply because I quite enjoy solving them this way. So I'm going to choose my little strip and put a few details on the diagram. So a width dx wide, height of that strip I'm going to say is y, whatever the y coordinates is at the top. It's a distance of x from the y-axis. The centre of mass will be at x comma y over 2. And I'm going to say that w is the weight per unit area. That's my preferred method. And so the weight of this strip will simply be w times by its area. And if it's a rectangle, we're just going to say it's w times by y dx. And of course, we bear in mind that dx is going to go towards 0. So modelling this as a rectangle is perfectly reasonable. Okay, so first of all I'm going to find the weight of the lamina, and to do that I'm just going to say it's w times by the area enclosed that's shaded in, so w times by the integral from 0 to 4 of y dx. Put the function in, perform the integration, and we end up with this, because of course when we integrate x to the half we get x to the 3 over 2 divided by 3 over 2, and dividing by 3 over 2 is the same as multiplying by 2/3. So we will get 2w over 3 times by substituting 4 in gives 8, so we get a weight of 16w over 3. I'm going to think about the moment of that strip about the y-axis and simply say it will be x times by its weight, which we already wrote on the diagram, wy dx. And then I'm going to think of the sum of all such moments. I'm not going to go through the use of sigma here. I'm simply going to say that I realise as dx goes towards 0, perhaps I should have written that in, but this will become the integral as shown. And if I think about the moment of the strip about the x-axis, then I will get y over 2 times by the weight, which is wy dx, and the sum of all such moments will simply give this expression here. Okay, so if I take moments about the y-axis, I can say that the centre of mass x bar times by the weight of the whole shape should be equal to the sum of the moments of these individual strips as shown. So I'm going to end up integrating x to the power of 3 over 2 on the right hand side, which of course will give me x to the power of 5 over 2 divided by 5 over 2. In other words, it will give me, sorry, I've simplified down a little bit there as you can see. Now I'll do the integration and I'll get eventually 3/16 times by 2/5 x to the 5 over 2 evaluated between 4 and 0. So I'll substitute 4 in and it'll give me this expression here, a little bit more simplification, which allows me to eventually work out x bar, which I can give as 12 over 5, or of course 2.4. To find out the value for y bar, the process is very, very similar, and I'll leave that to you. So now find y bar.